Section 1.7 is midpoint and distance in the coordinate plane. So when we talk about midpoint, if we're talking about midpoint on a number line, we're simply going to take the two values, add them together, and divide by 2, kind of like finding the average. So if I have one point at 2, and another point at 8, and I want the midpoint of AB somewhere in the middle, I'm going to take my two values, add them together, and divide by 2. So that will give me 10 divided by 2, or 5. So 5 is my midpoint. And we can tell that the distance from 2 to 5 is 3 units. The distance from 5 to 8 is 3 units, so clearly M is the midpoint between A and B. When we go to a coordinate plane, things change a little bit. So now we're talking about on an XY plane. All right, so if I'm looking for the midpoint, I'm going to add my x and, whoops, this is wrong. That should say x sub 1, x sub 2, and that should say y sub 1, y sub 2. So x sub 1 plus x sub 2 over 2, the average of the distance between the x's, and y sub 1 plus y sub 2 over 2, the average of the distance between the y's. So let's take a look at one of these problems. Whoops, let's back it up. So if I have two ordered pairs, for example, negative 1, 1, and 3, 5, and I want the midpoint, I'm going to find my midpoint by adding my x's and dividing by 2 to find the x-coordinate, adding my y's and dividing by 2. So that's going to give me 2 over 2 and 6 over 2, or the ordered pair 1, 3. And if we graphed these on a number line, negative 1, 1, and 1, 2, 3, 1, 2, 3, 4, 5, and then my midpoint, I'm going to call these endpoints A and B. My midpoint M is at 1, 3, and we can see that in fact it does appear to be the midpoint. I've proven it algebraically, and graphically it looks good as well. So those are both pretty straightforward formulas. I think you've seen them both before. But let's look at this second equation and see if we can do one other kind of problem. Given that the midpoint of CD is point M, which is at negative 2, 1, and one endpoint is at negative 5, 7, find the other endpoint. So up to now you've always been given the two endpoints. So let's take a look at our formula. Our midpoint, we'll call it x sub m, y sub m is the midpoint, is found by taking x sub 1 plus x sub 2 over 2 and y sub 1 plus y sub 2 over 2 and writing them as an ordered pair. So I've got my midpoint here. I know what the midpoint is, negative 2, 1, and I know one of my ordered pairs, but I do not know the other. So plugging in, x sub 1 is negative 5. I don't know x sub 2. Y sub 1 is 7. I do not know y sub 2. So this x value has to match with this x value. So we can write a separate equation, unknown x there, and the same for the y's. 1 has to equal 7 plus y sub 2 over 2. So solving these equations, multiply both sides by 2, add 5 to both sides. This side, multiply both sides by 2, subtract 7 from both sides. So I have an ordered pair now, my second ordered pair of 1, negative 5, which should be the other endpoint. So let's take a look at this graphically. Again, let me draw a coordinate plane here. So I was given a midpoint at -2, 1, and I was given one ordered pair at -5, 7. So I'll call that side A. And then I found my other point to be at 1, -5. And again, if I look at this graphically, it looks like I have found the proper endpoint to match the midpoint and the given value. So sometimes you will be given both endpoints. You plug them in to find the midpoint. And sometimes you'll be given a midpoint and one of your values, and you have to use two separate equations to find the other endpoint. So that's midpoint on a number line and a coordinate plane. Then we're going to look at distance formula. And this is something you should have seen as well. So the difference between the x values squared plus the difference between the y values squared. So let's take a look at a problem here. Let's say that I have these two ordered pairs. So again, my distance formula is the square root of x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2, sub 2 squared. And my values for x sub 1, and actually, yeah, let me do it this. Let's say x sub 1 and x sub 2 for our 2 points. So the square root of -7 minus 4 squared plus 5 minus a -3. So I've got the square root of -11 squared plus, plus 8 squared. So that's the square root of 121 plus 64, which is the square root of 185. And if you put that in your calculator, it's approximately 13.6. Okay, so distance formula, again, plugging in x sub 1, y sub 1, and x sub 2, y sub 2. All right. Distance in Pythagorean. Let's take a look at how the distance formula relates to Pythagorean. So if this is one point here, and let's put the other point here. So this is the coordinate 1, 2, 3, 4, 5, 6, 6, 6. And this is the coordinate of -2, 2. It's just coincident that I ended up with the same numbers. To find the distance here, I'm told to use the square root of the difference of the x's, minus, where'd my eraser go? Squared plus the distance between the y's squared. If I drew a right triangle here and used Pythagorean, so I'm going to get rid of my distance formula for a moment. If I wanted to have this distance squared and this distance squared to equal c squared, my c squared would equal, how many paces is this? 1, 2, 3, 4. This is 8 units. That's like taking 6 minus a -2. Right? Let me write it that way. 6 minus a -2 squared plus my b squared is 6 minus 2, or 4. So c squared equals 8 squared plus 4 squared. And to find c, I have to take the square root of that. So this is really just back to my distance formula. That's exactly how I found it. Okay, so Pythagorean and the distance formula go hand in hand. We'll look at that a little bit more in class. But that's it for the notes. Be sure you come with questions, but we're done for the video.